Good day everyone, and welcome to the fourth video illustrating the solution of a Delian problem doubling the cube. In the third video, we had a GeoGebra activity demonstrating the graphing solution of the Delian problem. Now let's have another GeoGebra activity. We are going to create a GeoGebra applet that dilates up and dilates down a cube. We will use the ratios x over y and y over x, where x is greater than y, as the scaling factors for GeoGebra dilation. Again, let's recap. For double mean proportion, it seems that x and y are side lengths, where a is to x is the proportion of volume A and side length x of the larger cube, where x is a cube root of A, and y is to b is the proportion of volume B to side length y of the smaller cube, where y is cube root of B. This seems to make sense because volume is equal to the cube of the side length. Hence, side length is the cube root of the volume, right? However, considering the arithmetic proof provided in the third video, x and y being side lengths seems invalid. So this needs a call for further study and research. Now let's revisit the theorem of similar geometric objects like triangles and cubes. We know that corresponding sides of two similar geometric objects are proportional, and the proportionality represents the ratio of dilation. And the dilation factor for doubling a cube is, what do you think? Yes, it's cube root of 2, which is approximately equal to 1.259923105. Here we are going to show that the factor for dilating down or reduction is 1 over cube root of 2, that's less than 1. When dilating down, we're going to use the ratio y over x, which is 1 over cube root of 2, where x is greater than y. Here, our given volume of the larger cube is A equals to 27 units. We're going to find the volume of the smaller cube B, which is the volume after the reduction. And the GeoGebra command to use is, of course, dilate. Okay, so we type dilate, and then the parameters are A, comma, and then the scaling factor, 1 over cube root of 2. In dilating down, or what we call as reduction, the dilating down factor should be less than 1. That's why we have the ratio y over x, which is equal to 1 over cube root of 2, where x is greater than y. So before our GeoGebra time, let me show you the formula when finding the side length of the smaller cube after the reduction. So we simply multiply the side length of the bigger cube, x, by the scaling factor, 1 over cube root of 2. So y is equal to x times 1 over cube root of 2. So here are the steps of the GeoGebra construction. So first, we're going to create a segment with 3 units. So we say segment with given length, then origin, then type 3. So the side length is 3. So this is the side length of the bigger cube. Then next, we're going to make a cube. So we're gonna call 3D graphics. So please observe. So we create a cube, then click on the endpoints. Alright, so this is now the cube with a volume of 27. So this is the larger cube. Alright, so we're ready to dilate. So just type in dilate and then call the cube A. the scaling factor. So scaling down is less than 1, so that will be 1 over cube root of 2. Alright, so let's now check. Is the volume 27 units double of 13.5 units? So what is the volume of the smaller cube here? It's 13.5 units. So is 27 units the double of 13.5? Yes. So the dilating down is successful. Here we're going to show that the factor of the dilating up or the enlargement is cube root of 2. So when dilating up, we're going to use the ratio x over y, which is cube root of 2, where x is greater than y. So our given volume of the smaller cube, B, is 8 units. And we're going to find the volume of the larger cube, A. And the GeoGebra command to use is, of course, dilate, and the parameters are B, comma, cube root of 2. Dilating up or enlargement, the dilation factor should be more than 1. So we're going to show that the ratio x over y is equal to cube root of 2, where x is greater than y. And of course, the formula when finding the side length of the bigger cube after enlargement will be x is equal to y times cube root of 2. So y, the side length of the smaller cube, times cube root of 2, the scaling factor. So here are the steps of the GeoGebra construction. Alright, so first we're going to create a line segment of length 2. So we say segment with given length, and then origin, and then 2. And now here in 3D, we're going to create a cube. So click here, and then the line segment. Okay. And so we're ready now to dilate up. So we call on the functionality dilate, and then we're going to call the smaller volume B, and the scaling factor is cube root of 2. Alright, so B prime is the bigger cube, and then B is the smaller cube. So is 16 the double of 8? Yes. So the enlargement process is successful. This completes the 4th video, and I encourage everyone to recreate the GeoGebra applet and answer the questions in this GeoGebra applet. So please don't forget to open an app like this and follow the instructions in the questions below. So thank you so much for watching, and I hope that you have learned something